Our next presenter is Mr. Allan Lahi. He's from Linear Motor Tube AL Engineering. Welcome.
Yes. Hello, everybody. I'm very glad to be here to present our idea. It started in the autumn when hearing the call for present some ideas or solutions to the Tallinn-Helsinki tunnel concept development, and a little bit about my background. My main education is mathematician, and I'm always PhD student. Not forever, I hope. I hope my degree will be get before the Tallinn-Helsinki tunnel is ready. And area is open innovation, and especially open innovation for SMEs. And I have worked a lot with small and medium-sized enterprises, 7 years within Bera Technology in Estonia, Nordic countries and UK. And not only develop the concepts, but sometimes like to do something with my own hands. And I'm always have some activities that calls casting sport. Have you heard? It's throwing or spinning or fly for distance and accuracy. And why I mentioned it, I got the idea from there. Because the spinning reels, for example, there is an old Abu Ambassador 2500. It works good, but if you replace, for example, the metal bearings with ceramic bearings, you achieve a reel with at least 3 times smaller resistance. By tuning of the tackle, for example, the best Haspel reel in the market, Shimano Stella, that cost approximately 600, 700, 800 euros. With some upgrade with 400 euros, you can get a very, very good reel. Like you can get a good car if you tune some cars that you can buy from the shop. By tuning of this tackle, I got some idea how to can be use a new tunnel, how can it be built, and started from the need. What is the main need in logistics? To be flexible, to be quick, and what actually happens in the airports. For example, if you need to have a 2 hours trip by plane, then you need to be 2 hours earlier in the airport to give your luggage out, to drop your luggage, then to wait in the security, to be just in time at the gate, wait there, to be just in time to wait the bus if necessary, to go to the plane, wait some tens of minutes in the plane sometimes. Then you have 2 hours flight, and after the flight you will wait from 10 minutes to half an hour until you can go out from the airport. That means that for 2 hours trip, you need to spend at least 4.5 hours of time, as usual. And similar things are in logistics. For example, if you move any good, you can check how the good is moving. You order something from Barcelona to Tallinn, you can check the points. It spends a lot of time in the warehouses on the way, but every minute that is spent in warehouse, it's wasted time. Every minute for the goods in warehouse is wasted time because you have spent work and energy and nobody can use it. And the biggest problem with existing trains is that they shall be effective. Effective means they shall be long. Trains contain a lot of dead mass to carry some goods or some people, and they need to carry as well sometimes the fuel, but usually the motors. Some more modern trains like maglev type trains or linear motor trains They don't carry the motors, but they have some heavy magnets that they need to carry. And idea was to put all the motors and all the heavy stuff outside the train and to build something quite light, something that can be modular, something that can be moved to whatever direction. Something that can be built from the plastics or composites, and you can put the container in, or you can put the passengers' seats in. It shall correspond to the 40 feet container or 40 to 48 seat bus space here. Something that's very flexible and something that you can join together for a longer train if necessary. If there will be train between Tallinn and Helsinki after every half hour, a long train for passengers. Now there are ferries for 2,000 people. That means that you need to have some check-in before the train. Check-in of 1,000 people or 500 people or 100 people takes much more time than check-in for 40 people. You can save a lot of time with check-in, and to put people move, or the trains or the modules move, not after half an hour, but every time where there is a demand, enough demand for that. And as well with the cargo. You don't need to wait a lot to put the necessary amount of containers together. Or I understand when there will be ship in the Arctic from somewhere and you need to move all the ship to the Bratislava or Milan or Berlin or this kind. It's another situation, but usually you need to move the goods in smaller amounts. Movement of goods in big amounts kills the small and medium-sized business to the end. And so-called efficiency kills the business too. The time of efficiency is over. It's time for the innovation approach everywhere in the economy too. By the usage of the ceramic bearings, you can save from friction. And the biggest friction will be air friction, but with a movement friction you can save a lot. And in our solutions, there are estimated 6 guides or 6 rails. Why 6? Or why not 8? Maybe 8 is better, but 2 can be not enough. Because if you make a lighter vehicle, then the mass center will go up and it needs to be stable. You need to have something for the stabilization in the up. And there are also on the rails linear motors. Linear motor is like regular electric motors that you are use or your drill or coffee machine or wherever, but it's only put onto the line, the electromagnets. It's quite simple, nothing new, nothing revolutionary, and it's in use in lot of places. And to the bottom 4 guides, because ceramics are a little bit different from metal and they are maybe not so withstanding. You need to have some reserve, some spare. And before the trials with models, we don't tell that ceramic bearings are the best there. Maybe hybrid ceramics, maybe some new kind of ceramics there. And if you look inside to the tunnels, there are 4 reels in bottom, 2 on top, and it can be used only not in the tunnels but as well on the ground or in the air. Just put the rails and put the trains or mag drives to go forward. It can be used everywhere, and maybe the first actual usage can be in somewhere in amusement park for small distance for light vehicle or somewhere in the city transport. The MacDrive solution in total seems quite similar to existing train, maybe, that something is moving, electricity is moving is forward. You can use energy from sea waves to generate electricity. It's not clear, shall we use AC or DC? DC is maybe more common in linear motors, especially in trains, but AC gives more opportunities to save the energy from the braking. 7% can be saved. When you start the movement from Tallinn to Helsinki or vice versa, then the first part to get the acceleration, that is most energy consuming part of the logistics, you can use a gravitation, and you can use a gravitation for braking at the end. And to keep on the linear movement, you need to much less of power. So by this solution, if it's in the tube or in tunnel, you can manage with, on some cases, with air pressure in front and back of the vehicle. So you can reduce the air pressure, but it's challenges for modeling and for trials. And if you like to look how it moves, so the first movement is here. And I'm very glad to present Hadi Alavi, who made a terrible and huge job in very, very short time. Alavi, Hadi, can you present you? It's not only mine business, and I'm very glad to go with this project and with this idea further. And what will happen next? The next challenge is to print out and prepare some 3D models that can work and test it in the actual lab scale environment. Then we can put them into some tube or tunnel or to the ground. Then we start to develop. When we reach from the lab scale development and prototype towards some pre-production and in real operational environment working solutions. That's all. And I like to thank some people, my family, because in the start was quite heavy, and I spoke with them a lot and they encouraged me. And to my colleagues from Tallinn University of Technology, my regular work is in the Entrepreneurship and Innovation Center of Mektori, and I started this idea like my private project, but now it will be wider, and I have consulted with my colleagues from the science, and I like to do it more and more, and perhaps some startups, some spin-offs will be created to develop further of this idea. And again, special thanks to Hadi. And if you like to have contact me, then it's very, very simple email address that I always have, and Hadi has his always. It ends with eesti.ee name and family name. So thank you for your attention, and I'm very happy to answer to the questions.